A tremendous amount of experimental work went into the material presented in this video pamphlet, and I would like to give credit where credit is due. The main body of the pamphlet, namely the first 3 chapters, were on the topic of agonist efficiency per se, and these were the 5 key people involved in that project. Snail Jayati and Prasad Purohit were first to appreciate that the binding energies, the weak and strong binding energies, shared a linear relationship, and that result was published in 2012. And I will say that result was a direct result of having an experimental measure of the unliganded gating equilibrium constant. That was done by Prasad Purohit and Tapan Nayak, and Archana Jha were the 3 people involved in that project. And because we had L0 measurement, we were able to use the green equation to calculate the high affinity binding energy, and that was what led to the discovery of the linear relationship between binding energies. Eva Bruhova was involved in measuring the effect of mutations of the binding site on that energy relationship. And she also was involved in the studies that I showed where the reefer for agonists in chapter 4. Eva Bruhova, Tapan Nayak, was a postdoc in the lab who did seminal work. He was able to study single binding sites and measure all of the rate constants of the thermodynamic cycle in isolation of each other, including binding to and dissociation from the open channel binding site, and established the validity of the green equation. And that was in 2017. And in 2019, he was involved in the first paper where agonist efficiency was defined. He was the lead author on that paper. So Nayak was a very critical player in the efficiency project. He is now at the University of Delhi in India. Dinesh Durthi is a postdoc in the lab who carried on the efficiency work by measuring efficiency from dose response curves in much of what was described in chapter 1. And he's now continuing to refine our definitions of our description of agonist efficiency classes and modes, and is working with the structural team in order to understand the structural basis of efficiency. This is the structural team, or was the structural team. I started along with Wenjian Zhang in the physics department of Buffalo, trying to understand the structural basis of ligand binding and agonist binding energies. And that work was done with Sushri Tripathi, who is now at Intel, where we tried to measure various structural parameters that were correlated with binding energy, with low affinity binding energy. And we were aided in that with another graduate student, Srirupa Chakraborty, who is now at Northeastern University as an assistant professor. The current work on efficiency is done in collaboration with M.J. Singh, who is in India, and graduate student, and Pooja Goyal, who is an assistant professor in chemistry at SUNY Binghamton, who are now involved in calculating MMP-BSA energies and relating these to agonist efficiency. They are working with Dinesh and Durthi on that project. I have to give credit to several key consultants. John Richard in the chemistry department at Buffalo, and Rob Colson, who is in the chemistry department at University of Pittsburgh, were very familiar with linear free energy relationships, and they schooled me both with regard to the rate equilibrium free energy relationships and the equilibrium free energy relationships that underpin efficiency. I thank them very much for getting me started in taking energy ratios, which is the key thing that in all aspects of this project. Eric Auerbach is my son, who one day at Thanksgiving, I think in 2016, I asked him. He's a fan. He's an energy engineer, and he told me that binding energy ratio that I was puzzling over for many years could possibly represent an efficiency. He studies the efficiency of pumps. And it turned out, I think he was right on that, and I give him credit for pointing me in the direction of energy efficiency. Andy Harris made me think hard about the zipper mechanism. I was waving my hands around, and only after discussing things with Andy did it become clear to me what I was trying to say. And finally, Fred Sachs and Feng Chin have been the brain trust in the biophysics department at SUNY Buffalo, and I always go to them when I have trouble with mathematics. And they are hard-thinking, brilliant people, and they have helped me think things out, both technical and otherwise. I've also had a very outstanding stable of technicians throughout my career. Jan Jordan, Mary Tierling, and Marlene Shiro have been with me for more than 20 years. Jan Jordan as a lab manager, Mary Tierling as our tissue culture technician, and Marlene Shiro as molecular biology. All three are absolutely outstanding and have tremendously increased the efficiency of our productivity. Tim Bailey was a molecular biology person for a few years and helped make many of the mutations that I showed in Chapter 4. Chris Nicolai is a software engineer, a computer programmer, and as was Jim Neal. And this team, Sachs, Chin, Nicolai, and Neal, are really the main people responsible for the QUB software, which we use to analyze the single-channel currents. This is an outstanding piece of software that's very useful, and without which we could not have measured all the rate constants what we did. And these are the guys that should get credit for that. And it's too bad NIH is no longer funding it, because it's going to die on the vine because it's not getting fed. But it was a great piece of software while it lasted. Chapter 4 was about the implications of agonist efficiency with regard to the gating conformational change. And this idea that there's a gating wave or a gating conformational cascade was the result of a tremendous amount of experimental effort. It started with Claudio Grossman and Ming Zhou. Claudio is now at the University of Illinois, and Ming is at Baylor, but was continued by Sudha Chakrapani, who's at Case Western, Giselle Sims at University of Illinois, Pallavi Bafma, Snail Jady, Prasad Purohit, Eva Bruhova, Tapan Nayak, Rahima Vij, Ananya Mitra, Shweta Gupta, Archana Jha, Dave Kadugan, that should be D. Kadugan, Stuart Licht, Jian Chen, Stephen Zhang, Ashutosh Vihani, all made contributions to the fee map that was shown in Chapter 4. These three at the end, Ox, Salomon, and Elenis, were mainly involved in studying desensitization, and in order to get our rate constants correct, we had to first really understand what was going on in desensitization. It's quite complicated, and without their work, we would not have been able to make the measurements accurately. Hopefully, I will be able to make a follow-up video on desensitization based on the work of these three guys. We did some theoretical work on phi, relating the phi values to transitions inside of a linear reaction chain. That work was started by Yu Zhou, who was a graduate student in the lab, but Eli Pollack from Israel Weizmann Institute and Surirupa Chakraborty and Stuart Licht all contributed to our thinking and are the theoretical basis of phi. Now, during the time that all this work was going on, we did have a few side projects trying to understand NMDA receptors and GABA receptors. And although this work, I didn't present any of that work in here, it did help or contribute to our thinking on what was going on with the ACH receptors. Turned out both the NMDA and GABA receptors were too complicated to make fundamental progress in what efficiency is all about. Although I think now that we have the foundations, we will be able to go back and do it, if someone will be able to do that using other receptors. So these are the people on mostly on NMDA receptor. It was Gabriela Popescu, Yu Zhou, Louis Premkumar, and Yongling Zhu, who is now at Northwestern. Louis Premkumar is at SIU. And Gareth Lima did work on GABA receptors that made us also think hard about what was going on. And Gareth is a physician who's now working in Mount Sinai in New York City. And finally, I want to recognize the funding agencies. I got started in my career with NSF, who took a chance on me when I was a postdoc at Buffalo, when I had newly arrived postdoc around 1984 or so. But since then, NIH has been very generous, have supported the work mostly on the Chapter 4 material, which is the 5 values. For some reason, they don't seem to like the efficiency project so much. I think they're wrong about this, but we'll see. NS has been the main contributor, and GHAM helped pick me up when my grant with NS terminated. So with that, I thank all these people, and I thank you for your attention.